Hello and welcome back to Tech and EduSpark Hub, where technology meets education. In today's lesson, we'll be looking at motion, and under this topic, we'll be looking at the definition of motion, types of motion, difference between distance and displacement, and we will also be looking at the speed, velocity, and acceleration. Also, we'll be looking at the equations of motions, and lastly, we'll be looking at motion under free fall. So stick with me till the end and let's enjoy the best out of the lesson. Firstly, what do we understand by motion? By definition, motion is said to occur when a body changes its position with time relative to a reference point. So let's write the definition of motion. So this is a simple definition of motion. Motion is said to occur when a body changes its position with time relative to its reference point. So when a body changes its position with time, we say the body is in motion. But if the position does not change, we say the body is at rest. So this is a simple definition of motion. So for example, we have example of motion. So we have a moving car and we also have a boy walking to a class. So these are examples of motion. A moving car, a boy walking to a class is an example of motion. So let's look at the types of motion. So moving to the types of motion, we have the first type, which is the translational motion. So in this type of motion, the object moves from one part to another. So it can be a rectilinear motion. So we can say a straight line. So this straight line will be rectilinear. And it can also be a curved path. So this can be a curvilinear. So this is all about the translational motion. It can be a straight line motion, which is also known as rectilinear motion. And it can also be a curved path motion, which is also known as curvilinear motion. So you can see the example of translational motion as displayed on the screen. So you can see we have a car moving, an apple falling from a tree, a ball moving in a straight line, and also a train moving in a straight line. So these are examples of translational motion. You can see them as displayed on the screen. So let's move to the second type of motion. And moving to the second type of motion, we have the rotational motion. So let me just write that down. We have B, which is the rotational motion. So in this type of motion, the object rotates around a fixed axis. So this is a simple definition of the rotational motion. The object rotates around a fixed axis. So let's look at examples of rotational motion. You can see the examples as displayed on the screen. You can see we have a spinning top, a Ferris wheel, the helicopter blade rotating, and the X rotating around a fixed axis. So all these are examples of the rotational motion. So let's move to the third type of motion, which is the oscillatory motion. So we have the oscillatory motion. So this is a type of motion that involve an object moving back and forth about a mean position. So this is a simple definition of the oscillatory motion. You can see we have a body moving back and forth towards a mean position. And the examples as displayed on the screen, you can see them. We have the simple pendulum, we have the circular motion, and we have a tuning fork. So these are all examples of oscillatory motion. And lastly, let's look at the last type of motion, which is the random motion. So we have the random motion. So the random motion, this is the irregular movement of a body without a defined path. So the random motion is just like a zigzag movement. So you can see example of the random motion as displayed on the screen. You can see we have a different plane moving together zigzag without direction. So we can see these are examples of the random motion. We also have the bombardment of particles. So it is random. They don't have a definite path. So these are all examples of the random motion. And this will be all on the types of motion. So let's move to another subtopic under this motion. So I'll be erasing this part so I can be able to write the subtopics. So the subtopic is relative motion. So let's look at what relative motion is all about. And moving to the relative motion, this is a type of motion that depends on the observer. So in this type of motion, which is the relative motion, the motion depends on the observer. So what is this relative motion trying to tell us? Let's look at an example. So let's say, for example, you are sitting down in a moving bus. So by relative motion, to you, you are at rest because you are sitting. And to someone outside, which is the observer, you are in motion. So this is what relative motion is trying to tell us about. It is a type of motion that depends on the observer. So we have an example. We said, let's say you are sitting in a moving bus. So to you, while you are sitting, you are at rest. So that is your own perspective. But to someone outside, which is the observer, it means you are in motion. And this is the way relative motion works. So let's look at the formulas of relative motion. So under this formula of relative motion, we have two cases or two scenarios. So for the first case, which is the case 1, if two bodies are moving in the same direction. For example, let's say body A is moving to the east. So we have body A moving to the east, and also body B is moving to the east. So in this case, their relative motion will be given as V1 minus V2. So this is a formula for the relative motion of a body moving in the same direction. You can see body A moving to the east and also body B moving to the east. So both bodies are moving in the same direction and their relative motion will be given as V1 minus V2. And moving to the second scenario or second case, we have the case 2. So if the two bodies are moving in an opposite direction. So let's say body A is moving to the east and body B is moving to the west. So you can see in this case, both bodies are moving in an opposite direction. So their relative motion will be given as V1 plus V2. So this is the formula for relative motions. So you can see if two bodies are moving in the same direction, we will subtract, while if two bodies are moving in opposite direction, we will add the velocity together. So let's look at an example or some examples under this relative motion. The first example as displayed on the screen says that if two cars are moving in the same direction, 30 meters per second and 50 meters per second, find their relative velocity. So in this case, we are giving our V1 to be equal to what? We have 30 meters per second, and also we are also giving our V2 to be equal to what? 18 meter per second. And the question says these two bodies are moving where? The same direction. And we said if two bodies are moving in the same direction, their relative motion will be given as v1 minus v2. So in this case, the relative motion, which is Rm, will be given as what? v1 minus v2, because they are moving in the same direction. So we have v1 minus v2. So our Rm will be given as what? 30 minus 18. So our relative motion will be given as 12 meter per second. So this is our final answer to question of this type. So we have option A as our final answer to this kind of question. And moving to the second example as displayed on the screen, the question says two trains move in an opposite direction at 25 meter per second and 35 meter per second. So find their relative velocity. So in this case, we are giving our v1 to be equal to what? We are giving 25 meter per second, and we are also giving our v2 to be equal to 35 meter per second. So the question is asking us to find their relative velocity. But the question is telling us that these two trains are moving where? In opposite direction. So they are moving in a different direction. And we said when two bodies are moving in an opposite direction, we have our relative motion to be given as v1 plus v2. So we have our Rm, which is the relative motion, to be equal to v1 plus v2. So in this case, our Rm, which is the relative motion, will be given as 25 plus 35. So we have 25 plus 35. So in this case, our Rm will be given as 60 meter per second. And this is our final answer to question of this type. So option B is correct to this kind of question. And that will be all about the relative motion. So let's move to our next subtopic, which is the difference between distance and displacement. So moving to the next subtopic, we have the distance and displacement. So what do we understand by distance and displacement? Do you think there is any difference between distance and displacement? Wait and find it out. So let's say we have our school. Let me just use a diagrammatic representation to just show you the difference between a distance and displacement. So let's say this is our school. So we have the school location, and let's say this is our home. And we have the home location. So from home to school, you can see this is a straight line arrow. So we can call this a displacement. So this is a displacement. It is the shortest distance covered or shortest distance possible from one destination to the other. And we have the distance. So we can have different distance. You can have distance like this. So from home to school, you can have a distance. So this is our distance. You can have another distance. So you can have another distance. So you can now see the slight difference or the simplest difference between distance and displacement. So displacement is the shortest distance covered from one destination to the other, while distance is the total part covered. So you can see we can have different distance from home to school. You can have several distance, but displacement is just one. You can only have one displacement because displacement is the shortest route ever to school. Why distance? You can have different, you can even have another distance that goes like this. So this is a simple illustration or a simple diagrammatic representation to tell us the difference between distance and displacement. So let's look at the key concept. So we have displacement. Let's look at distance first. So under this distance, it is the total length of part covered. Also, it is a scalar quantity. It is also positive. And we have displacement on the other hand. So displacement is the shortest distance between the initial and final position. So displacement is a vector quantity. So it means it has direction and magnitude and can be zero. So this is all to note about distance and displacement. So let's look at examples under this concept. So we have the example. For example, let's say a student walk 3 meters west and 3 meters east. So what is the distance covered? So the distance is equal to 3 plus 3, which is equal to 6 meters. So we said the distance is the what? Is the total length of path covered. So the student walked 3 meters west and 3 meters east. So the total length of the distance covered is what? 3 plus 3, which is 6 meters. Why the displacement in this case is equal to 0 meter. And why is the displacement equal to 0 meter? Because the distance is not regular or the distance is not uniform. So this is why the displacement is 0. So the student is walking 3 meters west and 3 meters east. So the distance is irregular. Assuming the student walks 3 meters from west to east, so we can say the displacement is 3 meters. But the student is walking 3 meters west and is also walking 3 meters east. So it is an irregular distance. So this is why the displacement is 0 in this case. So the distance is not uniform. And this is all to note about distance and displacement. So let's look at our next subtopic, which is the speed, velocity, and acceleration. And moving to the next subtopic, we have the speed, velocity, and acceleration. So let's look at this concept one by one. So let's look at the speed first. So the speed is given as what? Speed equals to the distance in meter over time in seconds. So this is the formula for speed. Speed is equal to what? Distance over time. So the distance is in meter while the time is in seconds. So we have the unit to be equal to what? Meter per seconds. So this is the unit of speed. The unit of speed is given as what? Meter per seconds. And speed is a scalar quantity. So this will be all about the speed. So let's move to the velocity. So we have the velocity. So the velocity is given as what? Displacement in meter over time in seconds. So this is the formula for velocity. Velocity is given as displacement over time, and the unit of velocity is equal to meter per seconds. So the unit of velocity is equal to meter per seconds, and velocity is a vector quantity. So velocity is a vector quantity, and this will be all about velocity. So let's move to the third concept, which is the acceleration. So we have the acceleration. So the acceleration is a change in velocity. So the formula for acceleration is given as v minus u over t. So this is the formula for acceleration. It is given as change in velocity over time, which is the final velocity minus initial velocity over time. So this is the formula for acceleration. And if there is an increase in velocity, so increase in velocity will lead to what? Positive acceleration. While decrease in velocity will lead to a negative acceleration. So it is this negative acceleration that we know as what? We know as retardation or deceleration. So this is all to note about the acceleration. We have the formula, which is change in velocity over time, which is v minus u over t. And we have increase in velocity, which will lead to what? Positive acceleration, while decrease in velocity will lead to a negative acceleration, also known as what? Retardation or deceleration. So let's look at some examples under the speed, velocity, and acceleration. So we have the examples. So the first example we have, as displayed on the screen, says that a body travels 240 meters in 12 seconds. Find its speed. So in this case, we are given the distance, which is what the body traveled. So we have the distance to be equal to what? 240 meters. And secondly, we're also given the time, which is equal to 12 seconds. And the question is asking us to calculate the speed. So whenever you want to calculate any question, the first thing to do is to write the given parameters in the question. So when you write the given parameters, you'll be able to know the formula that you are going to apply to that type of question. So in this case, we're given the distance, which is 240 meters, and we're also given the time, which is 12 seconds. And the question is asking us to calculate the speed. So looking at the formula for speed, we said speed is the distance covered over time. So we can apply this formula to get our speed. So in this case, you can see our speed is equal to the d, which is the distance, over time, which is the t. So in this case, our speed is equal to, what is our distance? Our distance from the question is 240 meters, while our time from the question is what? 12 seconds. So we have 12 seconds. So when you press this in your calculator, we have our speed to be equal to 20 meter per second. So don't forget your unit, which is what? Meter per second. So this is our final answer to question of this type. So option B is correct to this kind of question. We have 20 meter per second. So let's look at another example still under the speed, velocity, and acceleration. So the second example, as displayed on the screen, says that a car moves 100 meters east in 5 seconds. Find its velocity. So in this kind of question, as usual, we have to write the given parameters. So in this case, the displacement is equal to 100 meters and the time is equal to 5 seconds. So the question is asking us to find the velocity, which is unknown. So in this kind of question, you can see we have the displacement. The car or the body is just moving what? To east via what? 100 meters. So that is the displacement. So in our previous example, we said the body moves east and west. So there's no displacement. But in this case, it is just moving in one direction, which is the displacement of 100 meters. So the time is given as 5 seconds. And we said the formula for velocity is given as what? Displacement over time. So we can apply this formula to get our velocity. So we have our velocity to be given as our displacement over time. So in this case, our displacement is what? So we have velocity to be given as, what's our displacement? Our displacement is 100 divided by our time. Our time is 5 seconds from the question. So when we press this in our calculator, our velocity will be given as 20 meter per second. So don't forget your SI unit, which is meter per second. So option B is correct to this kind of question. So 20 meter per second is correct to this kind of question. So let's move to the third example, still under the speed, velocity, and acceleration. So the third example, as displayed on the screen, says that a body will increase its speed from where? 10 meter per second to 30 meter per second in 5 seconds. find its acceleration. So in this kind of question, the question says the body move or increase the speed from where 10 meter per second to 30 meter per second in 5 seconds, and we should find the acceleration. So we are given our initial velocity, which is our u, to be given as what? 10 meter per second. So why is our initial velocity 10 meter per second and not 30 meter per second? You can see the question says the body increase its speed from 10 meter per second. That means it is still moving at that 10 meter per second to 30 meter per second, and that is the final velocity. So our initial velocity will be 10 meter per second, while our final velocity, which is our v, will be equal to 30 meter per second, and the time given is what? 5 seconds. And the question is asking us to find our acceleration, which is unknown. So in this case, we know that our acceleration, which is a, is given as v minus u over t. So we have our acceleration to be given as what? V minus u over t. So we can substitute our formulas to this, or our parameters to this formula. So we have our a to be given as, what is our v? Our v is 30 minus, what is our u? Our u is 10 divided by what? Our time, which is 5. So we have our a to be given as 30 minus 10 will give you 20 divided by 5. So our a will be given as 20 divided by 5. When you press this in your calculator, you should have 4 meter per second square. So don't forget that the unit of acceleration, do I even write it? So the unit of acceleration is what? So your unit is in meter per second square. So that is the unit of acceleration. The unit of acceleration is what? Meter per second square, and that is why we are having 4 meter per second square in this case. So option C is correct to this kind of question. So let's look at our last example on speed, velocity, and acceleration. So moving to the last example, the question as displayed on the screen says that a body moving at 20 meter per second come to a rest in 4 seconds. Find its retardation. So in this kind of question, you can see the body is moving at 20 meter per second and the body come to rest in 4 seconds. And the question is asking us to find the retardation. So we're giving our u. So our u will be equal to what? 20 meter per second. So why is our u equal to 20 meter per second? Because the body is still moving at that velocity. So the body has not come to a rest yet. So the body is still moving at an initial velocity of 20 meter per second. And that is why we are having our u at 20 meter per second. So when the body comes to a rest, that will be our final velocity, because the body is now having a decrease in velocity. So our v will be given as the rest, which is 0 meter per second. So that is why we are having 0 meter per second, because the body is moving from one distance to another. So the second distance will be our final velocity, which is the rest. So it's given as 0 meter per second. And the time given is what? 4 seconds. And the question is asking us to find the retardation, which is our a. So the retardation is just a negative acceleration. So that is why we are still having our a as the retardation. So remember that the formula for acceleration is given as v minus u over t. So you can see that formula here. We have v minus u over t. So our acceleration, which is the retardation, will be given as what? What is our v? Our v is 0 minus, what is our u? Our u is 20. So we have 20 divided by, what is our t? Our t is 4 seconds from the question. So retardation is just what? A negative acceleration or deceleration. So our negative acceleration, which is the deceleration or retardation, will be given as a equals to what? 0 minus 20, which will give us minus 20 divided by 4. So in this case, our a will be given as what? Minus 5 meter per second square. So this is our final answer to question of this type. So you can see we are having a negative acceleration, which is also known as what? Deceleration or retardation. So option B is correct to this kind of question. Minus 5 meter per second square is correct. And this will be all on speed, velocity, and acceleration. So let's move to the next subtopic, which is what? The equation of motion. And moving to our next subtopic, we have the equation of a uniformly accelerated motion. So this is very important in solving any question under motion. So we have a four equation of motion. So the first equation of motion is given as, so we have the first equation, which is given as V equals to U plus AT. The second one is given as S equals to UT plus 1 over 2 AT square, while the third is given as V square equals to U square plus 2AS. And we have the last equation, which is the fourth equation, which is given as S equals to U plus V divided by 2 multiplied by T. So these are the four equations of motion. You have to know all these equations and master them and know when to use them. So for the first equation, we have the final velocity, initial velocity, acceleration, and time. So when you have all these parameters, you will use the first equation. And to the second equation, you can see there is distance here. So when they're asking about distance, or they're asking about, yes, when they're asking about distance, you will use this second equation of motion. And to the last one, which is the third one, when the time is not given, when you have a question that the time is not given, we are going to use this third formula, which is V square equals to U square plus 2AS. So this is when you are going to use this formula when the time is not given. And to the last one, when the distance is given but you don't have the acceleration. So when the distance is given and there is no acceleration, you are going to use this S equals to U plus V over 2 divided by what? Multiplied by T. And this is our equation of motion. So let's look at examples under this equation of a uniformly accelerated motion. So we have the examples. So the first example, as displayed on the screen, says that a body starts from rest and accelerates at 5 meters per second square for 4 seconds. Find its velocity. So in this kind of question, the question is asking us to find the velocity. So we are given what? The acceleration to be equal to what? 5 meter per second square. And also the question says the body starts from rest. So our initial velocity, which is u, we're given as 0 meter per second. So because the body is starting from rest, so that is the initial velocity or the initial speed that the body is coming from. So it is 0 meter per second. So that is our u. So in this case, we are given our t, which is for 4 seconds. And the question is asking us to calculate our final velocity, which is v, to be given as unknown. So looking at this parameter, which formula do you think is suitable for this parameter? In this case, we can use our v equals to u plus at, because the question is asking us to find the final velocity. We are given the u, which is the rest, and the a and the t. But we cannot use this because we are not given the distance. So this is out of it. Also, we cannot use this formula because we are having time in our parameters. So assuming we don't have time, that is when this formula can come in. And the last formula also, we cannot use it because we are not giving the distance. So we'll be using our first formula, which is v equals to u plus at. So our v will be given as u plus at. So substituting our parameters, we have our v to be given as, what is our u? Our u is 0 plus, what is our a? Our a is 5 multiplied by, what is our t? Our t is 4. So we have our v to be given as 0 plus 20. So our v is equal to 20 meter per second. And this is our final answer to question of this type. So option C is correct to this kind of question. 20 meter per second is correct. So let's look at the second example, still on the equation of motion. So the second example, as displayed on the screen, says that a body moving at 15 meters per second accelerates at 2 meters per second square. So find the distance covered in 2 seconds. So this is the second question. So let's write our given parameters. So we're given our initial velocity, which is our u, because the body is moving at what? 15 meters per second. And it accelerates at what? 2 meters per second square. So we have 2 meters per second square. And lastly, the question is asking us to calculate the time covered in 5 seconds. So we are asked to calculate the distance covered, which is our s, to be unknown. So how do we solve this question? You can see we cannot use our first formula, which is v equals to u plus at, because we are asked to calculate distance in this case. So the suitable formula in this case is s equals to ut plus 1 over 2 at squared. This third formula is only useful when you are not given the time. But in this case, we are given the time. And also, we cannot use this formula because acceleration, we can only use this formula when there is no acceleration, but there is acceleration in this case. So we are going to use the second formula. So note that this third formula is only useful when there is no time in your question. And the last formula is also useful when you have no acceleration. So in this case, we'll be using our formula, which is s equals to ut plus 1 over 2 at squared. So we'll be using s equals to ut plus 1 over 2 at squared. So our s, which is the distance that we have to calculate, is equal to, what is our u? Our u is 15 meter multiplied by our time. What is our time? Our time is 5 seconds. So we have ut plus, what is our half? We have half multiplied by, what is our acceleration? Our acceleration is 2 meter per second multiplied by t square. What is our time? Our time is 5. So we have our t square, which is 5 square. So in this case, you can see our s is equal to 15 multiplied by 5 will give you 75. So we have 75 plus. So these two can cancel these two. So we just have our 5 square. So in this case, we have our s to be equal to 75 plus. What is our 5 square? Our 5 square is 5 multiplied by 5, which will give us 25. So 5 square is the same thing as 5 multiplied by 5. So that is 5 square. So our s will be given as what? 75 plus 25 will give us 100. So we have 100 meter as our final answer to question of this type. So 100 meter is correct to this kind of question. So option A is correct to this kind of question. And this will be all about our second example. So let's look at another example still on the equation of motion. And moving to the third example, the question as displayed on the screen says that a car moving at 10 meters per second accelerates uniformly at 4 meters per second square. So find the distance covered when its velocity is 30 meters per second square. So in this kind of question, we're given our parameters. So let's write our parameters. So our u will be given as what? 10 meters per seconds. So how is our u 10 meters per seconds and not 30 meters per seconds? The question says the car is moving at 10 meters per seconds and accelerating uniformly at 4 meters per second square. So when the car is moving at 10 meters per second, that means the car is still in motion. It has not reached the final destination or the final velocity yet. So that is why we are having our u to be 10 meters per second. So the car is still moving at 10 meters per second at a uniform acceleration. So our a will be given as 4 meters per second square. And the question says, find the distance covered when the velocity becomes 30 meters per second. So the velocity has reached 30 meters per second, which is the final velocity. So we have our big V to be equal to 30 meters per second. And the question is asking us to find the distance covered as this velocity. So the distance covered at this velocity, which formula do you think is suitable among our 4 equations of motion? So we have our first formula, which is v equals to u plus at. We cannot use that because it does not have any distance. So we are asked to calculate the distance. So we can see there is distance here, there is distance here, there is distance here. So in this case, we cannot use this second formula because we are not having time in our parameter. So there is no t in our parameter. And I told you that this third formula is only useful when you don't have any time in your parameter. So in this case, there is no t. So we are going to use this third formula. And this one is useful when there is no acceleration. You can only use this fourth formula when you have no acceleration. But this third formula, you can use it when you have no time in your question. So in this case, we can use this formula, which is v square to be given as u square plus 2as. So this is our formula. So we know that our v square is 30. So we have 30 square equal to, what is our u? Our u is 10. So we have 10 square plus, what is our acceleration? We have 2 multiplied by 4 multiplied by, what is our s, which is the distance? We have s. So our s is not given. That is what we are asked to calculate, the distance covered when the velocity reach 30 meters per second. So in this case, 30 square will give you 900. So you have 900 equals to, what is our 10 square? 10 square is 100 plus what is 2 multiplied by 4 multiplied by s? You have 8s. So in this case, 100 can come to this side. So you have 900. So you have 900 minus, because when the positive sign is moving to the opposite direction, it will turn to negative. So you have minus 100 is equal to this 8s. So in this case, 900 minus 100 will give you what? 800 equal to 8s. So you can make s the subject of the formula. So you have x equal to 800 divided by 8. So our s will be given as 100 meter. So 100 meter is correct to this kind of question. So option C is correct to this kind of question. So 100 meter is correct. And this will be all on the equation of motion. So let's move to our last subtopic, which is the motion under a free fall. And moving to the last subtopic, we have the motion of a free fall under gravity. So in this case, instead of acceleration that we have been using, we just change it to acceleration due to gravity. So this is what motion under a free fall is all about. So the gravity, which is the g, is always equal to 10 meter per second square, unless specified to be 9.8 meter per second square. So in this case, if you are not giving g in your question, you will use 10 meter per second square. But if it is specified that g is equal to 9.8 meter per second square, that is when you will use 9.8 meter per second square as your gravity. And we have three equations of motion under a free fall. So the first one is, we have v equals to u plus or minus gt. So this plus or minus is just telling us that if the body is falling, so let's say like the body is falling down. So this is the body falling down. There will be plus g. So there will be plus gravity, because gravity will be pulling the body downward. But let's say the body is going up. So there will be minus g. So in this case, we have v equals to u plus gt. While in this case, we have v equals to u minus gt. So this is what the plus or minus is telling us about. So it can be plus gt or minus gt, depending on the question. If the question is saying the body is falling from rest or falling from anywhere, so the formula you are going to use is u plus gt. But if the question says the body is going upward, so you are going to use v equals to u minus gt, because when the body is going upward, there will be minus of gravity. So the gravity will not act on the body the way it will act on the body if the body is falling. So if the body is falling, there will be plus g. And if the body is going up, there will be minus g. And the second formula, we have s equals to ut plus 1 over 2 gt square. So it can be plus or minus 2. So depending on the question, if the body is going up, it will be minus gt square. But if the body is coming down, it will be plus half gt square. And we have the last formula, which is the third one, which is given as v square equals to u square plus or minus 2gs. So these are the three formula of motion under a free fall. So this plus or minus is just telling us the direction of the question. So you will see the application when we solve examples under this concept. So we can have v square equals to u square plus 2gs. So this also is also applicable when you have no time in your question. But this is applicable when you have what? Distance. So this distance can be h or s. So you can have something like h equals to ut plus 1 over 2 gt square. You can also have something like v square equals to u square plus 2gh. So it just depends on the way you want to put it. It can be distance or height or depth, any way the question puts it. So h or g is correct. You can use either way you want it. So let's look at examples under this motion. So the first question, as displayed on the screen, says that a body is dropped from rest. Find its velocity after 3 seconds. So in this kind of question, the question says the body is dropped from rest. So that means the initial velocity, which is u, will be given as 0 meter per second. And also find its velocity after 3 seconds. So the time is what? 3 seconds. So the question is asking us to find the velocity after 3 seconds, which is unknown. So our velocity is unknown, and our g, we are not giving g. And I said if we are not giving g, we will use 10 meter per second square. So we have 10 meter per second square as our g. But if the g is specified to be 9.8 meter per second square, that is when you will use 9.8 meter per second square. So looking at all these parameters, which formula do you think is suitable to use under the motion of a free fall? So you can see we have our v, u, and gt. So we can use this first formula. So the first formula is giving us v equals to u. So how do we know if this sign will be plus or minus? The question says the body is dropped from rest. So definitely the body will be coming down. So if the body is dropped like this, probably if I drop this marker, you can see it will be coming down. So it is going to be plus. So we'll be having plus g. So in this case, we'll be having plus gt. So our v, which is unknown, that is what we are asked to calculate. So v will be equal to, what is our u? Our u is 0 plus, what is our g? Our g is 10 multiplied by what? What is our t? Our t is 3 seconds. So our v will be giving us v equals to 0 plus. So 10 multiplied by 3 will give us 30. So we have v equals to 30 meter per second. So 30 meter per second is correct to this kind of question. So option C is correct to this kind of question. So let's look at another example still under the motion of a free fall. So moving to the second example, as displayed on the screen, the question says a body is dropped from an height. Find the distance falling in 4 seconds. So in this kind of question, the body is dropped from an height, just like I dropped this marker, so it will be plus because there will be influence of gravity against this body. So the body is dropped from an height. So the height of the body, so the u will be equal to 0 meter per second because the body will be at rest before it is being dropped. So we have 0 meter per second. So our height, which is the s, will be given as what? Unknown. And our time will be given as what? 4 seconds. So our g, it is not specified. So we have g to be equal to 10 meter per second square. So looking at all this, which formula do you think is suitable? I said we can only use this third formula when we are not given time. But in this case, we are given time. So we are going to use this second formula. So we'll be having our s to be equal to ut plus, because the body is being dropped, so there will be plus gravity. So we have plus 1 over 2 gt square. So in this case, our s, which is unknown, will be giving us, what is our u? Our u is 0 multiplied by, what is our t? Our t is 4 plus 1 over 2 multiplied by our gravity, which is 10, multiplied by, what is our time? So we have 4 square. So in this case, our s will be giving us 0 multiplied by 4 will give us 0 plus, so 1 over 2 multiplied by 10. So this we cancel this. We have 5 multiplied by 4 square. So in this case, our s will be giving us 0 plus 5 multiplied by, what is our 4 square? Our 4 square is 16. So x will be giving us 0 plus 5 multiplied by 16 will give us 80. So s will be giving us 80 meters. So 80 meters is correct to this kind of question. So option C is correct, and this is given as our final answer to question of this type. So let's look at the last example under the motion of a free fall. And moving to the last example, the question as displayed on the screen says that a ball is thrown upward with 20 meters per second. Find the maximum height. So in this kind of question, the ball is thrown upward with 20 meters per second. So our u will be equal to 20 meter per second. So why is our u equal to 20 meter per second? Our u is equal to 20 meter per second because when I throw this marker, we can only know the velocity that we use to throw this marker. We cannot know the maximum velocity that this marker will reach in the air. So we are having our u to be equal to 20 meter per second. So when I throw this, you can see we are having, that's the distance that I used to throw this marker. But our v, on the other hand, will be giving us 0 meter per second. And the reason why our v will be giving us 0 meter per second is because when I throw this, I can't know the maximum or the final velocity that this marker will reach in the air before it drops. So that is why our v will be giving us 0 meter per second. And the question, we are having our g, so the g is not specified. So the g will be giving us what? 10 meter per second square. And lastly, our h, also known as s, will be giving us unknown. So in this kind of question, you can see we're not giving the time. So there's no time in our question. So that is when this third formula comes in, because when you have no time, you will use this third formula. So applying this third formula, we have our v square equals to u square plus. So this will not be plus again because the ball is thrown upward. So there will be minus of gravity. We said when an object is thrown upward, there will be minus g. So instead of plus g, we have minus 2gh or 2gs. Any way you put it is okay. So you can use 2gh or 2gs. So h is still the same as distance, s is still the same as distance or height. So any way you put it is correct. So we're having v square equals to u square minus 2gh because the ball is thrown upward. So there will be minus of gravity. Assuming the ball is dropped, so that is when there will be plus g, which is the plus gravity. So in this case, we are having our v square. So v square is equal to 0 square equals to, what is our u square? Our u square is 20. So we have 20 square minus, what is our 2? 2 multiplied by 10 multiplied by h. So we have 0 equal to 20 square will give us 400 minus 2 multiplied by 10 will give us 20h. So you can bring 20h to the other side. So when you bring it, this minus will turn to plus. So we have 0 plus 20h to be given as 400. So 0 plus 20h will give us 20h. So which will equals to 400. So you can make your h the subject of the formula. So we have h is equal to 400 divided by 20. So our h will be given as what? 20 meters. So this is our final answer to question of this type. So option C is correct to this kind of question. And this will be all on the motion of a free fall, and also this will be all on everything about the first part of motion. So attempt this question on the screen and let me know your answer in the comments. I will let you know if you are right or wrong. And in our next lesson, we'll be looking at the second part of motion, where we'll be talking about the instantaneous velocity, the instantaneous acceleration, the velocity time graph, and the rest. And if you found this video helpful, or this video help you understand motion, don't forget to like this video so more learners can find it. Subscribe to Tech and EduSpark Up for more tech content and educational school lessons. And lastly, don't forget to share and turn on the notification bell so you won't miss any updates from Tech and EduSpark Up. And until next time, keep learning, keep coding, and I'll see you in the next one.